All right, the last part of 5A is types of studies and confidence intervals. Let's just look at a study and see if we can figure out. We're going to look at two different studies on some particular information and see if we can determine in what ways the two studies are different. Okay, so consuming adequate amounts of iron has been shown to promote brain function. Educational researchers are interested in whether regular consumption of dark leafy green vegetables, which are higher in iron, can help college students retain information better when studying for exams. Consider the following studies the researchers could conduct to gather the data. So they want to know about the impact of eating dark leafy green vegetables on retaining information when studying for exams. Okay, so study A. They could randomly select 10 large colleges and then randomly select 50 students at each college from sections of a particular algebra class. Okay, so they're setting it up as a simple random sample. The students would be randomly divided into two groups. Okay, so once again, the random. The first group would eat 1 serving of dark leafy green vegetables 4 days a week for 2 months leading up to exam. And the second group would not eat any dark leafy green vegetables. Then they would compare the group's average final exam scores. Okay, so that's one study. In the second study, the researchers could randomly select 10 large colleges and 50 students at each college from separate, blah, blah, blah. Okay, exactly the same. But here's where the difference comes in. The students would be asked to record their daily food intake for 2 months leading up to the final exam. Then the researchers would compare the final exam grades for students who ate dark leafy green vegetables at least 4 times per week and those who ate dark leafy green vegetables fewer than once per week. Okay, well, how are these different? Well, in study A, the students were told what to eat. And in study B, the students were asked what they did. So another way of saying that is the difference between them. Here they forced the behavior. They split them into groups and said, you're going to eat this, you're not going to. In study B, they just wanted them to follow along their natural diet and they were just going to record it. This is the difference between an observational study and an experiment. So, in an observational study, they observe or measure characteristics but do not attempt to influence or modify. In an experiment, researchers apply a treatment to some or all of the sample members and then observe the effects. So they force what's going on here. They tell people what's going on here. Here they just observe. Now within each of these, there are different parts of it. In an observational study, we're going to look at a retrospective or a case control study. It's an observational study that uses data from the past and in which sample naturally divides into two groups. The cases, the group who engaged in the behavior, and the controls, the group who did not engage in the behaviors. Then in an experiment, there are two groups. The treatment group, those are the people who receive the treatment being tested, or the control group, the group who does not receive the treatment. Okay, so let's go back to our study about the eating green vegetables. Okay. The observational study is study B. They didn't tell them what to do. They didn't apply a treatment. They just asked them to keep a log of what they did, and then they separated them out into two groups. Okay. So the cases, what they were looking at for, they engaged in the behavior under study, which is eating green leafy vegetables. So these are going to be students who ate the green leafy veggies, which I am going to abbreviate as as green leafy veggies. Okay. What is the control? The students who didn't, who did not eat the green leafy veggies. The experiment in this situation is A, because they split them into groups and said, okay, this group, you are going to eat the veggies, and in this group you are not. Okay. The treatment group, students assigned to eat the green leafy veggies, and these are students who were assigned not to eat the green leafy veggies. Okay. Now, why do we have some studies that are observational, and why do we have some things that are experimental? Oops, and I'm sorry, you can't see that. Well, it depends on what they're trying to find out. If, for example, you want to find out a treatment for a disease, you don't want to give the people the disease. You want to find people who have the disease and then split them into treatment and not treatment. I mean, cases and controls. That's going to be an experiment. I mean, an observational study. In an experiment, you would have to give them cancer and then give them the treatment. So that's just not, it's not ethical, and sometimes it's not practical and that sort of thing. Okay, so we've got 4 studies here, and we are going to determine whether they are observational. And if it is observational, it's going to be a case control, or if it's an experiment, we're going to identify the control and the treatment groups. Okay, so a National Cancer Institute found that groups having a single large mole had twice the risk of melanoma, a type of cancer, as compared with the other group that didn't have a single large mole. All right, well, this one is going to have to be an observational study, because you can't give people a mole. Well, I guess you could, but I mean, that's just dumb. Okay, so we're going to call this an observational study. So now we have to put it into cases and controls. Okay. Well, what we're comparing is people with single large moles and that don't have a single large mole, and then looking at their risk. Man, I gotta learn how to type. Risk of melanoma. Okay, so the cases would be the group with a single large mole, and the controls would be the group without a single large mole. And I would abbreviate that if I had to write it more than twice. Okay, a travel agency is putting together a pamphlet On travel safety for its customers, they hire a research firm to analyze data on a random sample of 300 people who have traveled in the last year. The firm finds that 8.5% of the travelers who put locks on their luggage experienced a theft while on the trip. 9% of travelers who did not put locks on their luggage experienced a theft. That kind of surprise. Well, that doesn't surprise me. Well, I don't know. I guess it doesn't really make a difference. Okay. All right. Now, there are two clues that give you that this is an observational study. They did a random sample of 300 people who traveled in the last year. Okay. They didn't go back and force them to put on locks and make them take another trip. They just polled them about what they did. So this is another observational study. So again, we need to find the cases and we need to find the controls. Okay. Well, the cases, they're trying to find experiencing theft and safety for its customer. So you could kind of do either one. So the cases I would put is the group with locks on luggage and the group without. Okay, let me straighten my pages here. Researchers wish to know if drinking green tea can improve skin health in young adults. 300 students from a large university in Texas were randomly divided into two groups. The first group drank 2 ounces of tea per week for 16 weeks. The second group did not drink any green tea. A skin health expert rated each student's overall skin health at the beginning and ending of the 16 weeks on a scale of 1 to 10. After 16 weeks, there was a 2-point average drop in the skin quality of the group that did not drink the green tea. There was a 4-point average drop in skin quality that did drink the green tea. Okay, that's weird. Okay, all right. This is going to be an experiment. They took these students, they put them into two groups and said, okay, this group is going to drink the tea and this group is not. And so here we have to find the treatment and the control. And the treatments are students who drank the tea and the controls are the students who did not. The green tea. Okay. 40 volunteers suffering from insomnia were divided into two groups. The first group was assigned to a special no desserts diet while the other continued desserts as usual. After 10 weeks, 83% of those who ate no desserts had less insomnia. Okay, once again, this is an experiment because the participants were split into two groups and told what to do. In an observation, you gather all the data and then split it into groups. Okay, so the treatments. The no dessert diet. And the controls were desserts as usual. There was no change. Okay. All right, so these are fairly straightforward. Now, remember back at the beginning and when we were doing all the fundamentals of statistics and we were talking about the sample statistic and the population parameter. Well, no matter how good the the data is, it's not a guarantee that the sample statistic is going to represent the entire population. So we use a margin of error is used to describe a confidence interval that is likely to contain the true population parameter. So we're going to say, okay, well, we came up with this sample statistic, and based on how confident we are, we're going to give you an interval where the population is going to stand. So here we have our sample statistic, and we're going to be given a margin of error. So our confidence interval is going to be our sample statistic, and we subtract the margin of error for the lowest value, and we add the margin of error for the highest value. And the notation is we have the sample statistic plus or minus the margin of error. And you have probably seen this in particular in elections. And it's really key to look at, because if you have an election that the results are 51-49, that's not a guarantee that the 51 is going to win. You have to look at that margin of error. If it brings it below 50, then they're not going to. Okay, so a candidate for state senate is interested in how she is polling. The independent polling company who gathers data says 54.6% of registered voters support the candidate with a margin of error of 6.2. Okay, the sample statistic is the 54.6. Okay. So now we're going to have our margin of error. Whoops, dropped my pen. Is 6.2%. So if I write this in its notation, it is going to be the sample statistic, which is 54.6%, plus, whoops, and that's not a very, or minus our sample statistic of 6.2%. So the confidence interval is between, we're going to take the low end, this minus this, our confidence interval now is between 48.4% and, to find the high end, 54.6 plus 6.2 is going to give us 60.8%. Okay. All right. So even though the sample statistic came up with 54.6, this is a fairly large confident margin of error, so it brings them below 50% to above 60. So is it reasonable that they will be elected? I'm going to say no on this, because the confidence interval dips below the 50% needed to win. Now, is it a good chance? Yeah. You know, the margin of error may be incorrect, and it's never a guarantee. Okay. All right. A 2006 Gallup poll interviewed 584 Americans about their pet ownership status. If Gallup reported that between 40% and 48% of Americans own a dog, well, we want to know what is the sample statistic, what is the margin of error, and then we have to write the findings in the notation. Well, notice that these are given in percent, and this is given as, we don't know what this is. I mean, they interviewed 584 people. So we are going to have to find that sample statistic, and we are going to have to find that margin of error. Well, I'm going to do that by going back up here. Okay. So what I know is that between 40 and 48% of people own dogs. Okay, so I know that 40% is my low and 48% is my high. So that means my sample statistic is right here in the middle. Now, if you can just see that, you can see that that's 44%. If you don't, remember what this middle is just you average them. So I would just take 40 plus 48 divided by 2, and that would also give me the 44%. So the sample statistic is 44%. So now I need to find the margin of error, which is from here to here. Well, that's going to be 48 minus 44, which is 4%. So if I want to write it in the appropriate notation, the results of this study are pet ownership status. There are 44% of Americans, plus or minus 4%. All right, well now that was where we quit in class, so let's go ahead and do this problem where we kind of put it all together here. Okay, so in 2016, a poll conducted by NPR, the Robert Wood Johnson Foundation, and Harvard's H.T. Chan School of Public Health explored the relationship between work and stress. One aspect they looked at was whether workers tended to use up their paid vacation days more or less frequently based on their pay level. So the graph below summarizes the results for the working adults. Okay, so these are full or part-time workers who say they used all or most of their paid vacation jobs. Low-paying jobs, only 39%. Average paying jobs, 51%. High-paying jobs, 52%. All right, so let's see here what else it says. The source, and here's some important things. There was a poll of 1,219 working adults in the U.S., and the margin of error is plus or minus 2.9 percentage points. Okay, was this an observational study or an experiment? Well, this is an observational study. They didn't force people to take vacation or to get a particular job and then, that. So they just observed what happened. Okay, so what is the sample? Well, the sample is 1,219 working adults in the U.S. with paid vacation days. Now our population is, let's look at what they wanted to study. Okay. Just workers in general. So our population is going to be workers, because that's what they want to know there. Is if they use their vacation days more or less frequency. Okay, so the population is workers whose employers offer paid vacation. Okay, so let's get some sample statistics here. In low-paying jobs, it was 39%. Average paying jobs, 51%. And in high-paying jobs, it was 52%. And then we've got this plus or minus 2.9 percentage points in the margin of error. So for the low-paying jobs, we have to take 39 minus 2.9, which gives us, whoops, I apparently have forgotten how to push buttons on my calculator. 36.1 to 41.9. For the average paying jobs, is going to be 48.1 up to 53.9. And on the high paying jobs, it is 49.1 to 54.9. Okay. All right. Is it reasonable to say that the majority of working Americans in low-paying jobs do not use? Remember, these are the people who do use. Okay. So the ones who do use is between 36 and 42. So it is reasonable. So yes, 36.1% to 41.9% do use their paid vacation. Which is less than 50%. Okay. Is it reasonable to say that a majority of working Americans in average paying jobs use most or all of their vacation? So this is in the average paying jobs. Is this more than 50%? No. The confidence interval drops below 50%. Okay, so that's it. The next page that's in your packet is on placebo effect and binding, which we are not going to do. So that's the end of 5A.